Unit 8 Energy Test. Number 1. A tennis ball falls off a shelf and bounces several times. Each bounce is lower than the one before. Soon the ball stops. Why doesn't the ball keep bouncing? A. The energy becomes stored in the ball. B. Some of the energy is changed into mass. C. Energy is transferred to the ground and air. D. The air and ground slowly destroy the ball's energy. Number 2. How does energy change when a person lifts a box and places it on a shelf? A. Energy is transferred from the person to the box. B. No energy is transferred, but the energy of the box increases. C. There is an overall increase in the energy of the person and the box. D. Energy is transferred to the person, but the energy of the box does not change. Number 3. What energy transfer occurs in a solar panel? What type of energy transfer occurs in a solar panel? A. Electrical energy is transferred to the panel when it is connected with an electrical source in a complete circuit. B. Electromagnetic energy is transferred to the panel when light waves from the sun are absorbed by the panel. C. Thermal energy is transferred to the panel when it is connected with an electrical source in a complete circuit. Or D. Mechanical energy is transferred to the panel when waves from the sun push against the panel and move it. Number 4. What energy transformation happens when you use a microwave oven? A. Mechanical energy is transformed into thermal energy. B. Thermal energy is transformed into electrical energy. C. Electrical energy is transformed into electromagnetic energy. D. Electromagnetic energy is transformed into electrical energy. Number 5. A spring toy, keeps moving for me. A spring toy is moving down steps as shown in the picture. So here's the picture right here. So the spring toy is moving down steps. What happens to the energy of the toy? A. The toy loses energy to the steps. B. The toy gains energy as it moves. C. The amount and type of energy of the toy stays the same. Or D. The amount of energy the toy has stays the same, but it changes form. Number 6. A forklift is used to lift a crate from the ground and place it onto a truck. What type of energy is transferred to the crate? A. Kinetic. B. Thermal. C. Elastic potential. D. Gravitational potential. Number 7. The gravitational potential energy of a ball is 20 J when the ball is dropped. If mechanical energy is conserved, which energies are possible for the ball as it falls? A. 20 J of kinetic energy and 20J of gravitational potential energy. B, 10J of gravitational potential energy and 25J of kinetic energy. C, 10J of kinetic energy and 5J of gravitational potential energy. Or D, 5J of gravitational potential energy and 15J of kinetic energy. Number 8. Leon completes a table to organize information about the different forms of energy. So here's the table, and you see the form of energy is chemical, and the description for chemical is what allows wood to burn. Okay, and then this one's blank. You're figuring out what form of energy is this description. The total energy associated with an object's position, shape, and motion. So again, which form of energy would complete the table? What would go here? A, nuclear. B, thermal. C, mechanical. Or D, electromagnetic. So which one of these is this definition? Number 9. Suppose a mechanical wave is traveling through medium A. When the wave enters medium B, it speeds up. Which of the following statements is true about medium A and medium B? Which is true? A, medium A is a solid and medium B is a gas. B, medium A is a liquid and medium B is a solid. C, medium A is a gas and medium B is a vacuum. D, medium A is a vacuum and medium B is a liquid. Number 10. The graph below shows the energy that a ball has. Predict how the graph will change if the ball is moving down toward the ground. So here's your graph, which is labeled energy of a ball, and you have gravitational potential and kinetic, and this is showing the level of energy in J. So again, predict how the graph will change if the ball is moving down toward the ground. A, the bar for gravitational potential energy will decrease and the bar for kinetic energy will decrease as the energy of the ball decreases. So saying both of these will decrease. B, the bar for gravitational potential energy will increase and the bar for kinetic energy will decrease as kinetic energy changes to potential energy. So B is saying this would go up and kinetic would go down. C, the bar for gravitational potential energy will decrease and the bar for kinetic energy will increase as potential energy changes to kinetic energy. So this time gravitational would go down and kinetic would go up. And lastly, D, the bar for gravitational potential energy will decrease and the bar for kinetic energy will remain constant, so the same as the energy of the ball decreases. So this one would go down and this one would remain the same. Just a reminder, guys, you can rewind this and go back to any question and have it repeated. You can pause it, and if you need anything repeated or need more time to work on a question. Number 11. Sarah heated 2 cubes of aluminum to 50 degrees Celsius. Cube A has a volume of 4 cubic centimeters. Cube B has a volume of 2 cubic centimeters. If the cubes do not touch each other, which of these statements is true? So if they do not touch each other, which one of these is true? A, cube A has a higher temperature than cube B. B, cube B has a higher temperature than cube A. C, cube A has more thermal energy than cube B. D, cube B has more thermal energy than cube A. Number 12. As Wilma holds a pan over a fire, the water begins to boil, as shown in the figure below. So here's a picture of the water boiling, and it's held over a fire. Which process is indicated by the letter X? So you're looking at X, which is right here inside the water, with those arrows. Is that A, radiation, B, insulation, C, convection, or D, conduction? Number 13. A scientist places a block of hot metal in a jar of cool water. Because energy is conserved, what must happen? A, the sum of the thermal energy of the water and the thermal energy of the metal will increase. B, the thermal energy of the water and the thermal energy of the metal will remain the same. C, some of the metal's thermal energy is transferred to the water as heat, but a small amount changes to mass. D, the thermal energy of the water will increase by the same amount that the thermal energy of the metal decreases. Going on to 14. There's a picture for number 14 right here with two beakers. One reading 1,000 milliliters and the other reading 100 milliliters. These two beakers contain different amounts of water, as shown. How does the temperature of the water in the large beaker, so here's the temperature, compare or contrast with the temperature of the water in the small beaker? A, the water in the small beaker has a greater temperature than the water in the large beaker because the water in the small beaker has less mass. B, the water in the large beaker and the water in the small beaker have the same temperature because the thermometers show the same readings. C, the water in the large beaker has a greater temperature than the water in the small beaker because the water in the large beaker has more thermal energy. D, the water in the large beaker has a greater temperature than the water in the small beaker because the water in the large beaker does not cool as quickly when heated. Jumping down to 15. Remember, you can pause these if you need to have more time. Number 15. As energy in the form of heat is added to an ice cube, it begins to melt. What causes melting? A, heat causes the molecules in the ice cube to expand and forces them apart. B, the transfer of thermal energy to the ice cube causes its molecules to move faster. C, heat removes thermal energy from the ice cube and causes it to become liquid water. D, the additional energy causes the bonds between hydrogen and oxygen in the ice cube to break. Number 16. Again, you have a diagram. Whoops, sorry guys. I keep doing that, huh? The diagram below shows a wave pattern. So here's the diagram with waves. You see A, B, C, D. What part of wave is represented by B? So what type of wave is this? A, crest, B, tra, C, amplitude, or D, wavelength? Number 17. The speed of a mechanical wave depends on the type of medium through which it travels. Which statement is true? A, all waves travel at the same speed through any medium. B, all waves travel at the same speed if no medium is present. C, electromagnetic waves require a medium, but mechanical waves do not. D. Mechanical waves require a medium, but electromagnetic waves do not. Number 18. Waves can be measured in many different ways. Ways can be measured in many different ways. So here's another diagram. What property of a wave is measured by F? So right here, what property would this be? Is that a period? B, frequency? C, amplitude? Or D, wavelength? Number 19. So you're looking at the same diagram. Okay. Again, waves can be measured in many different ways. What property of a wave is measured by E? So now we have this going up and down. Is that a period? B, frequency? C, amplitude? Or D, wavelength? Number 20. Use the following information and formula to solve for velocity. So the formula is right here. So velocity equals frequency times wavelength. So your frequency is given to you, which is 165 hertz, and then wavelength is 2 meters. So again, you're multiplying your frequency, which is 165, times your wavelength, which is 2, to get your velocity. Is the answer A, 330 meters per second, B, 167 meters per second, C, 163 meters per second, or D, 82.5 meters per second? Number 21. Some electric devices use direct current while others use alternating current. Which of the electric devices listed below uses mostly alternating current? A, digital camera, B, dishwasher, C, flashlight, D, MP3 player. Number 22. Plastic and wood are poor conductors of electric current, while copper and steel are good conductors of electric current. Which combination of materials would supply the most amount of resistance to an electric current? A, copper and steel, B, plastic and copper, C, plastic and wood, D, wood and steel. Number 23. This time you're given a table right here. The table describes the resistance of two different wires, so wire A and wire B. Based on this table, which of the following is most likely true? So wire A has a low resistance and wire B has a high resistance. So which of the following would be true? A, wire A is longer and thinner than wire B. B, wire A is shorter and thicker than wire B. C, wire A is a poor conductor of electric current. D, wire B is a good conductor of electric current. Number 24. Which of the following wires has the lowest resistance? A, a short, thick copper wire at 25 degrees Celsius. B, a long, thick copper wire at 35 degrees Celsius. C, a long, thin copper wire at 35 degrees Celsius. Or D, a short, thin iron wire at 25 degrees Celsius. Number 25. There are many different devices in the home that use electricity. Below is a diagram of 4 common electrical devices. Which electrical device runs on direct current? So you see device 1 is a toaster, device 2 would be a television, device 3 would be a flashlight, and device 4 would be a lamp. So which of these runs on direct current? Device A, which is the toaster, device 2, which is the television, device 3, which is the flashlight, or device 4, which is the lamp. Number 26. Most strings of outdoor lights are wired in a parallel circuit. Which of the following is the best reason why a string of outdoor lights should be wired in a parallel circuit and not a series circuit? A. Parallel circuits are safer to use than series circuits. B. The lights in a parallel circuit will light up brighter than the lights in a series circuit. C. If one light in the string burns out in a parallel circuit, the rest of the lights will continue to shine. D. You need to use more wires to construct a series circuit than a parallel circuit. Number 27. A student is building a simple circuit with a battery, light bulb, and copper wires. When she connects the wires to the battery terminals, the light bulb does not light up. Which of the following could explain why the bulb does not light? A. There is no energy source. B. The circuit is open. C. This circuit is too simple to light up a light bulb. Or D. Copper wires do not conduct electric current. Number 28, and again we have a diagram, so some pictures. You have circuit 1 here and circuit 2. The diagram below shows two examples of electrical currents. Which of the following statements about the circuits is correct? So again, the diagram shows two examples of electrical circuits. Which of the following of these statements about the circuits is correct? A. Circuit 1 is a parallel circuit and circuit 2 is a parallel circuit, so both are parallel. B. Circuit 1 is a series circuit and circuit 2 is a parallel circuit. C. Circuit 1 is a parallel circuit and circuit 2 is a series circuit. Or D. Circuit 1 is a series circuit and circuit 2 is also a series circuit, so both would be a series. So you're comparing and contrasting. Number 29. Oh, I keep doing this. Sorry, guys. We'll just do that. There we go. When making a complete circuit, a blank can be used to open or close the circuit. So what can be used to open or close the circuit? A. A battery. B. A switch. C. A light source. Or D. A wire. All right, and we have number 30. And you see a diagram again. So you see circuit element 1, circuit element 2, circuit element 3, and circuit element 4. Here's a diagram of a simple electric circuit. There are 4 elements to the circuit. They are labeled circuit element 1, circuit element 2, circuit element 3, and circuit element 4. What part of an electric circuit changes the electrical energy into another form of energy? A. Circuit element 1. B. Circuit element 2. C. Circuit element 3. Or D. Circuit element 4. And it looks like that is the end of your test. So just remember, if you have any answers you left blank, you can go back, you can rewind this, press play, and repeat any of the questions or answer options. Remember to go back and check over your answers and make sure you're happy with them all. And remember to make sure you answer all questions. Good luck!